The lake has given them food. But the night is cold, the catch is already fading, and hunger does not wait. A fish falls beside the fire. No one rushes to save it. Fire bites. Fire destroys. Every member of this community knows that. Then, the air changes. The smell is richer than raw flesh. The meat comes away from the bone. What looked ruined may be easier to eat. This moment is imagined. No archaeologist can recover a single forgotten night. But an extraordinary set of fish teeth suggests that roughly 780,000 years ago, early humans may already have understood something profound. Fire could do more than warm the body. It could transform food. Did cooked fish begin with an accident like this? Or did it require generations of careful experiments beside the water? How did humans learn to cook a creature that could burn in moments? Our story takes us to a place now called Gesher Benot Ya'aqov in present-day Israel. Around 780,000 years ago, water shaped every part of life here. The lake and wetlands offered fish, plants, birds and animals. Stone could be worked into sharp tools. Wood fed the fire. We do not know the names, voices or exact species of the people who lived here. Human bones have not been found at the site. Stone tools and the wider history of the region have led researchers to connect the occupation with Homo erectus, or related early human populations. But that identification is not certain. What is clear is that these people were not wandering without knowledge. They understood seasons, landscapes, materials, and the behavior of animals. Catching fish itself demanded timing and cooperation. In shallow water, a fish can be trapped by many hands. During seasonal changes, stranded fish may be gathered from shrinking pools. A sharpened stick or a simple barrier of branches might help. But such methods here remain reconstruction, not direct proof. Raw fish offers fat and protein, yet it brings problems. Bones hide in soft flesh. Heat spoils a catch quickly. Parasites and microbes are invisible dangers, even if early humans could not name them. And a large catch has little value if it cannot be eaten before it decays. Nearby is a possible answer: fire. But fire is not gentle by nature. Flames blacken the outside while leaving the center raw. A fish placed directly in a fierce blaze can break apart, fall into ash, or vanish into smoke. The challenge is not simply to put fish into fire, it is to control the distance between them. Imagine the lessons hidden in every mistake. Too close, and the skin burns. Too far away, and nothing changes. Leave the fish whole, and heat struggles to reach the center. Split it open, and the flesh cooks faster, but dries more easily. No written instructions exist. The only guide is attention, smell, color, texture, sound, and memory. One person notices, another remembers, a child watches. A useful accident becomes an action that can be repeated. But how can modern science detect such behavior after nearly 800,000 years? At Gesher Benot Ya'aqov, archaeologists found large quantities of fish remains, especially teeth from carp-like species. Some teeth appeared in clusters near areas associated with repeated fire use. The pattern suggested that fish had been brought to particular places again and again. Researchers then examined the crystal structure of tooth enamel using X-ray diffraction. Heat changes the size and organization of enamel crystals. Those microscopic changes can act like a record of temperature. The results, published in 2022, were consistent with heating at lower controlled temperatures, rather than direct exposure to intense flames. The study proposed that early humans may have cooked fish at the site about 780,000 years ago. That would place possible fish cooking hundreds of thousands of years earlier than much of the previously accepted evidence for regular cooking. Yet science advances through questions, not certainty alone. The teeth do not prove a recipe. They cannot tell us whether fish rested above embers, lay on warmed ground, sat near a dying fire, or cooked inside some temporary covering. Critics have noted another possibility. Fish remains might have been discarded at the cooler edge of a fire and heated without deliberate cooking. So the careful conclusion is not, "we know," it is, "the evidence suggests." And within that uncertainty lies our real mystery. What kind of knowledge would controlled heating require? One possible reconstruction begins when people stop treating every fire as the same. A new flame is fierce and unpredictable. But after the flames fall, glowing coals release slower, steadier heat. Ash can soften that heat further. A warmed stone holds it. Damp leaves may protect delicate flesh for a short time. None of these exact methods has been proven at this site, but each could emerge from materials and observations available in the landscape. Perhaps the first improvement is distance. Fish is placed beside the coals, not inside the flames. Perhaps the next is a barrier, a stone, a green branch, a leaf, or a layer of earth between food and fire. Perhaps someone discovers that waiting for high flames to disappear produces better food than rushing toward them. The breakthrough is not one perfect invention. It is control of heat, time, and attention. The change is immediate. Heat loosens flesh from bone. It alters smell and taste. It can kill many harmful organisms and make nutrients easier for the body to use. Small bones become easier to see and remove. A child takes a cautious piece, then another. But one success is not yet technology. The next fish cooks too long. Another receives too little heat. Leaves dry and catch. A stone cracks. Wind changes the fire. Knowledge grows through correction. The community learns to feel heat without touching it, to read the color of embers, to recognize the smell of flesh changing, and to judge when a fish is ready. What began as chance becomes a shared sequence. Catch, clean, protect, heat, wait, and divide. This is the climax of the discovery. Not a dramatic tower of flame, but a quieter achievement. People teaching fire to become gentle. Cooking changes more than the fish. Food can become softer for the young, the old, or anyone with damaged teeth. A shared hearth creates time for other tasks, while heat does part of the work. The group must gather fuel, protect the fire, prepare the catch, and decide when to eat. Cooperation becomes part of the meal. Controlled fire also demands planning. Someone must remember where dry wood can be found. Someone must keep embers alive. Someone must notice when the wind turns dangerous. The meal connects the knowledge of many people. We should not imagine a modern dinner table or familiar conversation, but the basic human pattern is recognizable. Food transformed by heat, gathered around a shared source of light. Cooking could have widened the range of edible foods and reduced the energy needed for chewing and digestion. Over long periods, cooked diets may have influenced human biology and social behavior. Scientists still debate when regular cooking began and how large each effect was. The evidence from this lakeshore is important precisely because it pushes that debate deeper into time. Today, people across the world grill, steam, bake, smoke, wrap, and roast fish in countless ways. Those traditions are recent compared with this ancient shore, and none can be traced directly to it. Yet all depend on the same invisible skill, controlling heat rather than simply creating it. The greatest transformation may be mental. A fire is no longer only an event in nature. It becomes a tool with settings: fierce flame, steady coal, gentle warmth. And once people learn that natural forces can be adjusted, watched, and repeated, new possibilities appear everywhere. Nearly 780,000 years later, the people are gone. Their gestures, experiments, and meals left no written record. What remains is small enough to rest on a fingertip. Fish teeth, altered crystals, stone tools, and traces of repeated human activity. Together, they support a remarkable possibility. Early humans at Gesher Benot Ya'aqov may have cooked fish with controlled heat far earlier than researchers once expected. But the evidence does not close the story. It keeps the question alive. Was the fish placed near embers, protected by leaves, heated on a surface, or inside a simple earthen arrangement? Or did some remains reach low temperatures for reasons unrelated to cooking? Archaeology can narrow the possibilities, but it cannot yet select one final scene. Still, imagine what followed if deliberate cooking truly became familiar here. A catch no longer had to be swallowed as it came from the water. Taste could be changed. Texture could be controlled. Food preparation could become knowledge, passed from one generation to the next. And that creates another unanswered question. Once people learned to cook fish slowly, did they also discover how to keep it longer? Drying it in the sun, exposing it to smoke, or carrying it away from the lake? The first recipe vanished. The human habit of discovery did not.